Need to dynamically add or modify tools in your FastMCP server at runtime while keeping your core server configuration clean. We'll use ToolInjectionMiddleware to inject a simple calculator tool on the fly, showing how this advanced pattern complements FastMCP's standard at MCP tool decorator approach. You'll see how type hints automatically generate JSON schema and how docstrings become tool descriptions, all while maintaining the right Python, not protocol boilerplate philosophy that makes FastMCP tools so intuitive to create. From FastMCP server middleware tool injection, import ToolInjectionMiddleware. Def my tool fn a int b, int, return a plus b. My tool equals tool. From function, fn equals my tool fn, name equals my tool. MCP, add middleware tool injection middleware, tools equals my tool. This demonstrates the middleware-based extension pattern for dynamically augmenting server capabilities, specifically showing how FastMCP supports both static tool definition via decorators and runtime tool injection through middleware. The code illustrates the more advanced tool injection middleware approach, which complements the standard at MCP tool decorator pattern by enabling tools to be added or modified during server operation without requiring redeployment. The distinctive aspect is how FastMCP maintains its right Python, not protocol boilerplate philosophy across both patterns, using Python type hints for automatic JSON schema generation and docstrings for tool descriptions. The pattern works through FastMCP's layered middleware pipeline, where ToolInjectionMiddleware intercepts requests to merge dynamically injected tools with statically defined ones. When a tool call arrives, the middleware makes both decorator-defined tools added via at MCP tool or server tool, and middleware-injected tools available in a unified namespace. This follows the chain of responsibility design while preserving type safety, as the same type hint processing that generates schemas for decorated tools also applies to injected functions like myToolFn. This approach solves the problem of runtime extensibility while maintaining clean architecture, particularly valuable when building AI tooling systems that require dynamic capability adjustment. The middleware pattern shines in scenarios like plugin architectures, A/B testing of tool variants, or hot reloading of tools without server restarts. While decorators remain the standard for static tool definition, the middleware injection provides complementary flexibility with the trade-off of slightly more complex control flow, as middleware execution order becomes significant in determining tool availability and behavior. Let's break it down line by line. From FastMCP server middleware tool injection, import ToolInjectionMiddleware. Imports ToolInjectionMiddleware, an advanced FastMCP component for dynamic tool injection at runtime. Unlike the standard at MCP tool decorator pattern, this middleware enables adding tools programmatically during server execution, using Python type hints for automatic JSON schema generation and docstrings as tool descriptions. The pattern maintains FastMCP's right Python, not protocol boilerplate philosophy, while supporting scenarios where tools must be registered or modified after server initialization. Def my tool fn a int b, int. This defines the raw Python function that will be converted into an AI callable tool. The type hints automatically generate JSON schema validation for inputs and outputs, while the function's docstring becomes the tool description visible to the LLM. This follows FastMCP's core philosophy. Write Python functions with type hints, not protocol boilerplate. Return a plus b. This implements the tool's actual business logic that the AI will execute. The function signature with type hints automatically generates the tool's JSON schema, while the docstring becomes the tool's description for the LLM. This follows FastMCP's write Python, not protocol boilerplate philosophy, where Python constructs directly define the AI interface. My tool equals tool. From function, fn equals my tool fn, name equals my tool. This converts the Python function into an AI callable tool using FastMCP's factory pattern, where the function signature, type hints, and docstring automatically generate the tool's JSON schema and description for the LLM. While the @MCP tool decorator is the standard approach for static tool definition, tool from function enables programmatic tool creation, particularly useful for dynamic scenarios where tools must be added at runtime. The middleware pattern shown here extends this by allowing tools to be injected into the server's execution context without modifying core configuration, maintaining FastMCP's write Python, not protocol boilerplate philosophy. MCP, add middleware ToolInjectionMiddleware, tools equals my tool. This registers your tool using FastMCP's middleware pipeline, enabling dynamic injection at runtime. While the @MCP tool decorator is the standard approach for static tool definition, this middleware pattern shines when tools need to be added or removed dynamically, like plugin systems or runtime configuration. The function's docstring becomes the tool description for the LLM, and type hints automatically generate the JSON schema, keeping the write Python, not protocol boilerplate philosophy intact. Tool registration patterns. FastMCP provides multiple ways to expose Python functions as AI callable tools, with that MCP tool decorator being the standard approach, while ToolInjectionMiddleware enables dynamic runtime injection. Type hints and docstrings automatically generate complete tool schemas, eliminating manual protocol definitions.
The decorator that disappears becomes the protocol.